Welcome to Lucid Mind Chemistry channel. In this video, I'll be solving Chemistry A-Levels multiple choice questions. Paper 12 from February-March 2022. For question timestamps and other useful information, please visit video description. Question 1. The first ionization energy of potassium K is 418 kJ per mole. The first ionization energy of strontium Sr is 548 kJ per mole. Which statement helps to explain why strontium has a greater first ionization energy than potassium? Part A. The charge on a strontium nucleus is greater than the charge on a potassium nucleus. Now this is true statement because ionization energy it is directly proportional to nuclear charge. Greater the number of protons, greater will be the ionization energy. And the second thing is that ionization energy is inversely proportional to the size of atoms. Now strontium has more proton number as compared to potassium, so therefore this could be the true statement. Part B. The outer electron in a strontium atom experiences greater shielding than outer electron in a potassium atom. Now greater shielding means that the outermost electrons it is shielded from the nucleus, so therefore the ionization energy should decrease. So greater shielding means less ionization energy. But in this case strontium has greater first ionization energy, so therefore this statement is incorrect. Part C. The outer electron in a strontium atom experiences spin pair repulsion. Now strontium is in group 2 of the periodic table and in s orbital it has a pair of electrons, as all members of group 2 have s2 configuration. So therefore it will experience spin pair repulsion, but still the ionization energy is greater, so therefore due to spin pair repulsion the ionization energy should be less. So this statement also does not describe why strontium has greater first ionization energy, so it is incorrect. Last one is part D. The outer electron in a strontium atom is further from the nucleus than the outer electron in a potassium atom. Again this statement describes that as ionization energy is inversely proportional to size, so therefore farther from the nucleus means that it should have less ionization energy. But it is not the case, so therefore this is also incorrect. The only correct option that seems to describe this statement is A. Question 2. What is the electronic configuration of magnesium 2+? For this you need to know about the atomic number. The atomic number of magnesium is 12. So it means there are 12 electrons in a neutral magnesium atom. Let's do the electronic configuration of neutral magnesium atom. It will be 1s2, 2s2, 2p6, 3s2. Now as the charge is +2, it means 2 electrons are lost. So we can remove 2 electrons and the left electronic configuration will be 1s2, 2s2, 2p6. Therefore correct answer is A. Question 3. Compound X contains the element carbon, hydrogen and oxygen only. 2 grams of X produces 4 grams of carbon dioxide and 1.63 grams of water when completely combusted. What is the empirical formula of X? They have given mass in grams, so therefore we can convert this into moles. For carbon dioxide we have CO2 and molecular mass is 12 plus 32, 44. For water we have H2O and Mr is 2 plus 16 equals 18. Now we can find the number of moles of carbon dioxide. Mass in grams divided by Mr. So it is 0.090 moles of carbon dioxide. Similarly for water, it is 1.63 grams divided by Mr. It also comes equal to 0.090 moles of H2O. Now we can find the number of moles of these given compounds. We have CH2O, so it is 12 plus 1 plus 32. it equals 45. Now we can also find the number of moles. Number of moles will be equal to 2 grams divided by 45. It comes equal to 0.044. Now second one is C2H2O. So we have 2 carbon atoms, so it is 24 plus 2 hydrogen plus 1 oxygen. So the total molecular mass comes equal to 42. And number of moles will be 2 grams divided by 42, which is equal to 0.047. In third one, again we have 2 carbon atoms, 4 hydrogen atoms, so 24 plus 4 plus 16, it is equal to 44, and finding the number of moles, it comes equal to 0.045. Similarly, the last one, 12 plus 2 plus 32, 46, and number of moles is 0.043. Now as we can see that in part A and in part D we have just single carbon atoms present. So for both of them they will give same moles of carbon dioxide. For example, for A we can write the chemical equation CH02. It combusts to form carbon dioxide and water. Now as we can see that the number of carbon atoms on reactant and product side is same, so therefore number of moles must be same. So we can say that the mole ratio is 1:1. If there are 0.044 moles of CHO2, then there must be 0.044 moles of CO2. But in this case the number of moles are not 0.044, so therefore A is incorrect. Similarly for D we have 1 carbon atom on the reactant side, so again it will be the similar case. The ratio between carbon dioxide and CH2O2 is again 1:1. As we have same number of carbon atoms, so it should also be equal to 0.090 moles, but this one is 0.043, so therefore this is also wrong. Now we can do the equation for part B. Part B is C2H2O. Now we can combust in the presence of oxygen to form CO2 and H2O. Now we can see that there are 2 carbon atoms on the reactant side, 1 carbon atom on the product side. So in order to balance, we need 2 moles on the product side or 2 CO2. Now carbon atoms are balanced. Similarly, balancing hydrogen is already balanced. And we have 3 oxygen atoms on the reactant
42,
side and 5 oxygen atoms
paper
on the
11,
product side. So
paper
we can
12,
make
paper
it
13,
4.
from October-November 2021.
Now first finding the ratio between these two, we have 1
paper
mole of
42,
C2H2O and 2 moles of
from
CO2 are
February-March
formed.
2021.
So as the number of moles is
For question
0.047
timestamps
for
and other useful
C2H2O.
information, please visit video description.
So it will be
From
equal
October-November
to X. We can cross
2021,
multiply and find the number of moles of CO2. So 0.047 multiplied by 2, it will be equal to 0.094 moles of CO2. But in the question we had 0.090 moles, so therefore this is incorrect. Now doing the same for part C, we have C2H4O. We can write the balanced equation. Balancing number of carbon atoms, again we have 2 on the product side. Now we have 4 hydrogen atoms, so we can write 2 with H2O. 6 oxygen are present on the product side, while we have just 1 with this and 2 with this. So we can make it 5 by 2. Now the ratio according to balanced equation is 1 mole of this forms 2 moles of CO2. So in the question we had 0.045 moles of C2H4O. So 0.045 will be equal to X, cross multiplying. 0.045 into 2, it is exactly equal to 0.090 moles. So this is true for CO2. Let's do it for H2O too. So for water, we can see again the molar ratio is 1:2. As in the balanced equation, we have 1 mole of C2H4O which forms 2 moles of water. So again it is 0.045 ratio X. So we can cross multiply with this one. So again it will be equal to 0.090 moles of water. So both come correct for C2H4O. Therefore answer is part C. Question 4. For which molecule is the dipole moment 0? Now dipole moment is present in polar compounds which have partial charges. First one is CH3Cl. Now we can draw this one. We have carbon, 3 hydrogen atoms and 1 chlorine atom. Now chlorine is more electronegative, so therefore half portion of molecule is partial negative, while hydrogens are less electronegative, so therefore this half is partial positive. So we have polar molecules, so therefore there must be a dipole moment. In second one we have CH2Cl2. We can draw this one. We have carbon, 2 hydrogens, 2 chlorine atoms. Again we can see that there is partial charges. We have partial positive on one side, partial negative on second side, so therefore this is also polar and there must be some dipole moment. For third one again we can draw. We have C, on one side we have hydrogen and on other side we have 3 chlorine atoms. So as chlorines are more electronegative, so this is partial negative, this one is partial positive, so there must be a dipole moment. In last one we have CCl4. Carbon is in the center. We have 4 chlorine atoms and all are arranged in a tetrahedron with bond angle of 109.5. So now due to the presence of chlorine atoms, we have only electronegative elements, so therefore there is negative charge surrounding the carbon atom. There is no partial positive center, so therefore according to vector addition, the dipole moment must be equal to 0. So correct answer is D. Question 5. Which dot and cross diagram is correct for Al2Cl6? Now aluminum chloride, it exists in the form of dimer in which 2 AlCl3 are present. Aluminium belongs to group 3 of the periodic table, so it has 3 electrons in the outermost shell, while chlorine, it belongs to group 7, so it must have 7 electrons in the outermost shell. Now aluminum makes 3 covalent bonds with 3 chlorine atoms, so as we can see in this structure, 3 covalent bonds are formed with 3 chlorine atoms, but still aluminum has only 6 electrons in the outermost shell, so it is electron deficient. And for octet rule we need 8 electrons in the outermost shell to be stable, so therefore it needs 2 more electrons, and these 2 electrons are provided by the chlorine atom of the second aluminum chloride. So we have 3 single covalent bonds and 1 coordinate covalent bond. Similarly for this aluminum chloride, again we can see that aluminum makes 3 single covalent bonds with 3 chlorine atoms, and 1 coordinate covalent bond is formed between chlorine atom of second molecule with this aluminum, so that its outermost shell is complete or the octet is complete. So therefore this is the correct structure for the dimer of aluminum chloride. In part A we can see we have ionic bond, which is incorrect. Let's look into part C and D. In part C, we can see aluminum makes 4 single covalent bonds, which is not possible as aluminum just has 3 electrons in the outermost shell. In part D, aluminum makes another bond with aluminum which is covalent, which is also incorrect. So the only correct option that is correct for a dimer of aluminum chloride is B. Question 6. The boiling points of some hydrogen halides are shown. We have HCl, HBr, HI. The boiling point increases. What is the explanation for the trend in boiling point for hydrogen halides from HCl to HI? First one, we have the bond energies of hydrogen halides increase from HCl to HI. Now you should remember that in boiling point, the bonds, they do not break, only the intermolecular forces of attraction are overcome. So the bond energy, it does not have anything to do with boiling point, so therefore A is incorrect. Part B, there is an increase in strength of the intermolecular forces of attraction from HCl to HI. Now as boiling point, it depends on the intermolecular forces. For example, we have this molecule and this molecule. So when heat is applied, the intermolecular forces, they reduce and therefore it converts into gaseous state. So part B could be correct option. Part C, the intermolecular hydrogen bonds become stronger from HCl to HI. Now for hydrogen bonding, we need either fluorine or oxygen or nitrogen of one element and hydrogen of another element. Now fluorine, oxygen and nitrogen are not present, so therefore there must be no hydrogen bonding. In part D, there is an increase in bond polarity from HCl to HI. Now going down in group 7, we can see that the electronegativity, it decreases as we move from chlorine to bromine and bromine to iodine. So when electronegativity decreases, the bond polarity should also decrease. This option is incorrect. The only correct answer is therefore B. Question 7. Elements X, Y and Z are all in first two periods of the periodic table. The following electronegativity values are shown. We have X, Y and Z. The electronegativity, it increases. Substances exist with formula XZ, YZ and Z2. Which row puts these substances in order of increasing melting point? Now in the periodic table, as we move from left to right, from metals to non-metals, what happens that electronegativity, it increases. This is because the size decreases and nuclear charge increases. So therefore it means that Z must be on the right side of the periodic table and X must be on the left side of the periodic table. Now we can also find the electronegativity difference to find out whether the molecule is polar or non-polar. First one is X and Z. For Z, electronegativity is 4. For X, electronegativity is 1. So 4 minus 1, the difference is 3. Second one is we have Y and Z. So we have 4 and 2.1. The electronegativity difference is equal to 1.9. Third one is Z2. So as we have electronegativity of 4, so 4 minus 4, the difference is 0. So when we have 0 electronegativity difference, it means that the molecule is non-polar and only weak intermolecular forces are present among the molecules. So it must have the least melting point of all these three. So we have lowest melting point of Z2. Then we can see that the highest electronegativity difference is between X and Z. So it means there are poles present in this molecule. So one must be partial positive and second must be partial negative. So due to the presence of poles, the melting point must be high. So we can say that X and Z has the highest melting point. And then in between these two, we have Y and Z. So correct answer is therefore C. Question 8. The equation for the reaction 1 is shown. We have this reaction. Glucose, it converts into carbon dioxide and forms ethanol. Enthalpy of combustion is given. For glucose, we have the value A, and for ethanol, we have the value B. What is the correct expression for the enthalpy changes of reaction 1? Let's find out the enthalpy change of reaction. We have C6H12O6. We can use the triangle and Hess's law to find out the enthalpy changes. Now we have CO2 and C2H5OH. Now number of moles are also given. We have 2 moles of CO2 and 2 moles of ethanol. This shows the enthalpy change of combustion in kilojoules per mole. Now combustion means that the product is carbon dioxide and water. So we can write the products. For glucose combustion, it will be CO2 and H2O. Similarly, for ethanol combustion, it would be the same. Now we can balance the number of carbon atoms. We have 6 carbon atoms on this side, 6 carbon atoms on this side, and we can write 3 with CO2 to make it 6. And we have 12 hydrogen atoms on this side, 12 on that side, so we can write 6 with H2O. Now enthalpy change of combustion is the energy change when 1 mole of compound is combusted in excess oxygen. So now as we have 1 mole of C6H12O6, so enthalpy of combustion value will be A. But we have 2 moles of C2H5OH in this one, so enthalpy change of combustion for ethanol will be 2 into B. This one is reaction 1, so we can write delta HR. Now let's find out the triangle using Hess's law. As we can see that both arrows, they point in this direction, so therefore this is the common product. And both arrows start from this or originate from this one, so this is the common reactant. So this is one step and these are 2 steps. According to Hess's law, the energy change in one step is equal to the sum of energy change in 2 steps. So we can write, for this one we have A, it is equal to delta HR, plus we have 2 into B or 2B. Now we can find the enthalpy change of reaction. Del HR will be equal to A minus 2B. So correct answer is part D. Question number 9. Nitrogen monoxide is an atmospheric pollutant that is formed inside car engines by an endothermic reaction between nitrogen and oxygen. This is the chemical reaction. N2 reacts with O2 to form NO, and as they have said that this is endothermic reaction, so therefore enthalpy change will be positive. Which diagram correctly represents the energy profile for this reaction? For endothermic reaction, the reactants absorb energy, so therefore the energy of product is always greater than the energy of reactants. So product should be greater than reactants. Let's see in part C and D, the energy of product is less than the reactant. This is incorrect as this one is for exothermic reactions. Now among A and B, we can see the activation energy. It is the energy required for the reactants to convert into the transition state. So this one is correct. Similarly, this one is also correct. And now the enthalpy change. Enthalpy change is the energy difference between reactants and products. In both cases, we can see that the direction of arrow is changed. So if the arrow is above, it means that the energy is absorbed, and this is for endothermic. And for exothermic, we draw the arrow in such a way that it is facing downwards. So therefore this one is incorrect. The correct answer is therefore part A. Question 10. 2 half equations are shown. We have this one equation and this is second equation. 3 electrons are gained, 2 electrons are lost. The equation for the reaction between manganate 7 ions and sulfite ions is shown. We have this equation. They have given U, V, W, X, Y and Z. Which statements are correct? Let's first balance these half equations. We have different number of electrons, therefore we can multiply with a number to make them equal. So we can multiply equation 1 with 2 to make it 6 electrons, and we can multiply equation 2 with 3 to make it 6 electrons. Now the number will be multiplied with every species present, so it will be 2 MnO4 negative, 4 H2O, 6 electrons, 2 MnO2 and 8 OH negative. Similarly for second equation, now it will be 6 OH negative, 3 SO3 negative 2, 3 sulfates, 3 water molecules and 6 electrons. Now we can add both of these equations together. We have 2 MnO4, so we can write MnO4 negative. We have 4 water molecules. Again we have 6 OH negative, 3 SO3 negative 2. Now on the product side we have MnO2, OH negative, SO4 negative 2, water and 6 electrons. Now electrons gained are 6, electrons lost are 6, so therefore I am not writing them in the equation. They will cancel out. Let's write the number of moles. We have 2, 4, 6, 3. Then for MnO2 we have 2, OH is 8, sulfate is 3, water is 3. Now another thing, we have to find out the similar reactants and the products. We can see OH negative, they are similar as 6 moles are consumed and 8 moles are produced. So overall we can say that if this is 0 then this must be 2. So 2 moles of OH negative are formed. Now let's see what is the value of U. U is MnO4 negative 2, so it is 2. For X we have MnO2, it is also 2. For Z we have OH negative, so it is also 2. So statement 1 is correct. For 2 it says manganese is reduced to oxidation state plus 4. Let's find the oxidation state of Mn on the reactant side and Mn on the product side. We have MnO4 negative. So Mn, 1 oxygen is negative 2, so 4 oxygen will be negative 8, overall charge is minus 1. So Mn equals plus 8 minus 1 equals plus 7. So it is plus 7 on the reactant side. And now on the product side we have MnO2. So we have Mn, 2 oxygen, for 2 oxygen it will be negative 4, overall charge is not given, so it is 0. Mn equals plus 4. So it moves from plus 7 to plus 4. So it is reduction. So statement 2 is also correct. Part 3, sulfur is oxidized from oxidation state plus 4 to plus 6. Let's look into sulfur. We have SO3 negative 2 on the reactant side, and in product we have SO4 negative 2. So we can write, we have sulfur, 3 oxygen, it will be negative 6, overall charge is negative 2. For this one we have sulfur, 4 oxygen, which will be negative 8, overall charge is minus 2. So S equals minus 2 plus 6 plus 4. In this one S equals plus 8 minus 2 plus 6. So it moves from plus 4 oxidation state to plus 6 oxidation state. This statement is also correct. As all three are correct, therefore answer is A. Question 11. Hydrogen peroxide, we have H2O2. It decomposes to form water and oxygen. The reaction is catalyzed by bromide ions. We have bromide 2Br negative, which is present on the reactant side as well as formed on the product side. So therefore this is the catalyst. Which row is correct? We have to find out the type of catalyst and whether it is oxidation in step 1. Now there are two types of catalysts. One is heterogeneous, one is homogeneous. Homogeneous means they are in the same phase as compared to the reaction. So as we can see in the reaction, we have aqueous form, Bromine is also aqueous. In the second part again we can see that bromine is aqueous, all other are also aqueous, so therefore the type of catalyst must be homogeneous. Now in step 1 we can see whether bromide are oxidized or reduced. So bromine, it goes from -1 oxidation state to bromine molecule which is 0. So from -1 to 0 it is always oxidation. So we can say that bromide ions are oxidized to bromine molecule. Correct answer is therefore C. Question 12. Hydrogen and iodine, they react to form hydrogen iodide in exothermic reaction. So we can write the enthalpy change. Enthalpy change will be negative. The equation is shown. This is the chemical equation. A 1 meter cube reaction vessel contains hydrogen, iodine and hydrogen iodide gases at equilibrium. This is the total volume of the reaction vessel in which all three are present. The temperature is changed such that the total pressure in the 1 meter cube vessel doubles. So for gases, we know that temperature is directly proportional to pressure. So if we increase the temperature, the pressure also increases. It means that this change is increase. What is the effect on the value of Kp? Kp is the constant for pressure and on the position of equilibrium. Now as this reaction is exothermic, so for exothermic we know that when temperature is increased according to Le Chatelier principle, the equilibrium, it moves in the backward direction. This is because heat is the product. As the reaction is exothermic and you are increasing the temperature, it means you are increasing heat. So therefore when product increases, the reaction moves to the backward direction. So therefore equilibrium moves to the left. We can see this one and this one. Now second part is the effect on the value of Kp. Now what is Kp? Kp is the pressure of product, which is hydrogen iodide. It is in gaseous state and there are 2 moles, so it will be squared divided by the pressure of each reactant. So we have pressure of hydrogen and pressure of iodine. Now from this equation we can see that Kp, it is directly proportional to the pressure of product. So if the pressure of product increases, Kp will also increase. If the pressure of product decreases, Kp will also decrease. Now as the temperature was increased, so therefore the concentration of product has reduced. When concentration will get less, pressure will get less. When pressure is less, it means Kp is also decreasing. Correct answer is therefore A. Question 13. Diethyl zinc, we have C2H5, Zn is added to NaOH aqueous, 2 reactions occur. This is the first reaction in which, in the presence of water, it converts into zinc oxide and ethane. In reaction 2, we have water, zinc oxide and hydroxide to form zinc hydroxide. In these reactions, which compounds act as Bronsted-Lowry acids? Now Bronsted-Lowry acid means proton donor. Whichever species donates protons, so therefore that will be Bronsted-Lowry acid and the other species will be base. Now we have 2 reactions. First one is this one. Let's see what's actually going on in reaction 1. We have C2H5 whole 2 Zn. So it is CH3, CH2, CH3, CH2 and then we have zinc. Now charge on zinc is +2. So to balance the charges, we have equal charges on both of them. They are making bonds with this to make a complex. Now water is present and water will donate protons. 2 protons are donated from water. So now CH3, CH2 will gain a proton as the charge is negative. So it will gain a proton and it will become CH3, CH3. So as we have 2 of them, so it will be 2 moles of C2H6 and in water we also have oxygen which is left. So zinc +2, it will react with oxygen -2 to form zinc oxide. Now in this equation we can see that water is providing protons, so therefore water is Bronsted Lowry acid. Now reaction 2, we have water, zinc oxide to form zinc hydroxide. Let's draw the structure of product. In product we have 1 zinc, we have 4 hydroxide ions present. Now as overall charge is -2, it means that zinc is +2 and each OH is -1. So we have 2 hydroxide ions from this. We need 4 hydroxide ions, and we have water and zinc oxide. Now what happens that water, it can provide proton to this oxygen to make it OH4. So water will give proton, and this proton is gained by this oxygen. Now we can see we have 2 OH, third OH and fourth OH. So 4 OH is present. It means that water is donating a proton, so therefore proton donor is acid. Correct answer is therefore B. Question 14, which statement about atoms and molecules is correct? Part A, the molecular formula of compound is the simplest whole number ratio of atoms of each element in a compound. This is not the molecular formula, it is called empirical formula. So this is incorrect. Part B, 1 mole of any substance contains 6 exponential 23 atoms. Now this is not true for any substance, this is true only for elements. For example, if we have water, in one molecule 3 atoms are present, 2 atoms of hydrogen, 1 atom of oxygen. So 1 mole H2O will have 3 into 6 exponential 23 total atoms. So B is also incorrect. C, the relative atomic mass of an element is the ratio of the average mass of one atom of the element to the mass of an atom of carbon-12. Now this is not the mass, it is actually 1/12 of the mass of carbon-12. For example, oxygen, if it is 16, it is equal to the average mass of one atom of the element, which is 16, divided by the 1/12 of mass of atom of carbon-12. Carbon-12 is 12. So 12 by 12, it cancel out. So it is equal to 16. So it should be 1/12 of carbon-12. This is incorrect. Last one is part D, the relative formula mass. This is for ionic compounds, is the sum of the individual atomic masses of all the atoms in the formula. Let's suppose we have sodium chloride, sodium is 23, chlorine is 35.5, so the sum of atomic mass, it will be equal to the relative formula mass. So this one is correct. Answer is therefore D. Question 15. The Boltzmann distribution for 1 mole of gas at temperature T is shown. These are the number of particles on y-axis, and on x-axis we have energy, and this is the curve. Area under the curve, it shows the number of molecules present. 1 mole of the same gas is added and the gas remains at temperature T. So it means temperature is not changing while only the number of moles are changing, so it means number of molecules will change. Which dotted curve shows the distribution with the added gas? So if you are adding 1 mole of the same gas, it means that the area under the curve will increase. So as temperature remains constant, so it means that the curve, the shape of the curve, it will not change. So let's look into the given options. In A, the shape of the curve has not changed, it is the similar hump, and the area under the curve, it has increased, so it could be A. In part B, they have moved hump in the forward direction. Previously this one was here, now it is over here. So this can only happen if temperature is increased. Area under the curve remains same, so it means it is incorrect. In part C, they have moved it backwards, so therefore this should be for decrease in temperature, so this is also incorrect. In part D, again they have moved it in the forward direction, so this is incorrect. The only correct option is part A. Question 16. In the reaction shown, the concentration of both X and Y are reduced to half of their original value, whilst keeping the total volume of solution constant. Simultaneously, the temperature is increased from 298 to 348 Kelvin. Which prediction is definitely true? Now, concentration has decreased, it means number of molecules has decreased. Temperature has increased, it means average kinetic energy will be more. Part A, a smaller proportion of collisions between particles of X and particles of Y will be successful. Now, this is not true because as we can see, concentration has decreased, but on the other hand, temperature has increased. So therefore, it must not be smaller proportion, it can be equal proportion. So the statement 1 is incorrect. Part B, the average kinetic energy of particles of X and particles of Y will increase. Now, average kinetic energy, it only depends on the temperature, it does not depend on the concentration, because in concentration the number of molecules are decreasing, but the average kinetic energy cannot be decreased. So as we are increasing temperature, temperature is increasing kinetic energy, so overall average kinetic energy will increase. This is definitely true. Part C, the rate of the reaction will be unaffected. Now, the rate of reaction, it depends on the concentration of the reactants and it also depends on the temperature. So therefore, we cannot say that the reaction will be unaffected. Maybe the reaction is more dependent on the temperature, so therefore the rate of reaction will increase as the temperature is increased, or maybe it is more dependent on the concentration of reactants, so therefore as concentration decreases, the rate will also decrease. So we cannot definitely make this statement true. Part D, the frequency of collisions between particles of X and particles of Y will halve. Now, the frequency of collisions, it depends both on the concentration and on the temperature. When concentration is decreased, frequency of collisions will decrease. But if temperature is increased, the frequency of collision will increase. So therefore, we cannot say that it will halve. Correct answer is part B. Question 17. A student investigated the chloride of period 3 element. This is what the student wrote down as a record. The compound was a white crystalline solid. It dissolves easily in water to give a solution of pH 12. When placed in test tube and heated in a roaring Bunsen flame, the compound melted after several minutes heating. What can be deduced from this record? We have different options. Part A, it says at least one of the recorded observations is incorrect. Let's see other parts first because they have given compounds. We have magnesium chloride, phosphorus chloride and sodium chloride. Part B, the compound was magnesium chloride. Now magnesium chloride is white crystalline solid. It dissolves easily in water because it is salt to give a solution of pH 12. Now this is incorrect because magnesium chloride, it gives a pH equal to 7 or slightly less than 7. Part C, the compound was phosphorus pentachloride. Now PCl5, it is acidic because it forms HCl when dissolved in water. So for acidic, the pH should be less than 7. So this is also incorrect. Then it says that the compound was sodium chloride. Now sodium chloride, when dissolves in water, it forms sodium ions and chloride ions. There is no effect on pH and pH of water remains 7. So it means that this observation is incorrect. So we can say that at least one of the recorded observations is incorrect. Correct answer is therefore A. Question 18. The elements in period 3 and their compounds show trends across the period from sodium to chlorine. Which row is correct? First one is the electronegativity of the elements. Second is the acid-base behavior of oxides of the elements. Now as we move in the period, what happens that atomic number increases, or you can say nuclear charge increases, size decreases because number of shells they remain same. So when size remains same and nuclear charge increases, it means electronegativity also increases, because electronegativity is directly proportional to nuclear charge and it is inversely proportional to size. Second thing is acid-base behavior. Let's write elements of period 3. Let's suppose we have sodium oxide. Then along the period 3 we have aluminum oxide. Then we can move further to sulfur dioxide or sulfur trioxide. Now metal oxide, they are basic in nature. Sodium oxide is basic. Aluminum oxide is metal oxide, but this one is amphoteric in nature as it can behave both as acid as well as a base. Sulfur dioxide is non-metal oxide. It dissolves in water to form acidic solution. So this one is acidic oxide. So we can see the trend is from basic to acidic. Correct answer is therefore C. Question 19. The table shows the melting points of silicon dioxide and phosphorus oxide. SiO2 is 1883 Kelvin, P4O6 297 Kelvin. Which statement explains the difference between the melting points of silicon dioxide and phosphorus oxide? Now melting points, it depends on the type of bonding or intermolecular forces of attraction. As we can see that in this one we have silicon dioxide, which is giant covalent structure. In SiO2, each silicon is attached to 2 oxygen atoms, and each oxygen atom is in turn attached to 2 silicon atoms. And again each silicon is bonded to 2 oxygen atoms, so this structure it goes on continuously. Now in melting, what will happen that we have to break some of the bonds to make it liquid, so therefore the melting point is quite high. While in second one we have phosphorus oxide and it exists in the form of simple molecule. As in one molecule we only have 4 atoms of phosphorus and 6 atoms of oxygen. So therefore due to simple molecule, the intermolecular forces are easily overcome, so therefore melting point is low. Part A, the bonding of the oxides changes from ionic to covalent. Now in both we have covalent, as phosphorus is a non-metal, oxygen is a non-metal, so it has covalent bonding. In silicon dioxide we have covalent bonding. So this one is incorrect. Part B, the metallic character of the elements decrease across period 3. Now this statement is true because it moves from metals then to non-metals. But this statement does not have anything to do with the melting point, so therefore we cannot make this true for this question. Part C, the oxidation number of the element increase from silicon to phosphorus. Oxidation number definitely increases. Silicon is in group 4, so it is +4. Phosphorus is in group 5, so it could be +5. Oxidation state does not have anything to do with melting point. Part D, the structure changes from giant molecular to simple molecular. Now this is the statement that is related to the melting point. Giant molecular always have high melting point and simple molecular have low melting point because of the presence of intermolecular forces. Giant molecular such as we have diamond, we have silicon dioxide, they always have high melting point. So correct answer is therefore D. Question 20. Equal masses of calcium carbonate. We have calcium nitrate, barium carbonate, barium nitrate are thermally decomposed. The volume of gas produced in each experiment is measured under same conditions. Which compound will produce the greatest volume of gas? We have calcium carbonate. Calcium is 40, carbon is 12, 3 oxygen is 48. So it is 100. For barium carbonate, again the carbonate is 60 plus we have barium is 137. So molecular mass equals 197. Then we can move to nitrate. We have calcium nitrate. Calcium is 40. We have 2 nitrogen atoms 28, 6 oxygen atoms 96. So it is equal to 164. Similarly for this one, nitrate equals 124 plus we have 137 for barium, it will be equal to 261. Now we have equal masses and we have different MR. Now number of moles, it is equal to mass in grams divided by molecular mass. If mass is constant, the number of moles is inversely proportional to molecular mass. So we can say that greater molecular mass means less number of moles and less molecular mass means greater number of moles. Lesser molecular mass will make more number of moles. So more number of moles will produce more volume of gas. As we have only 2 types of compounds, one is nitrate, one is carbonate. So we can take out the one having least number of molecular mass. So we have 100 for this. This is less as compared to barium carbonate. And this one is less as compared to barium nitrate. So these two will make greatest volume of gas. Now let's see which one produces greater volume. We can write the balanced equation for calcium carbonate. We know whenever it is decomposed, it forms oxide, metal oxide plus carbon dioxide gas. Now the equation is already balanced, so we can write the ratio. It is 1 to 1. In balanced equation, as 1 mole of calcium carbonate forms 1 mole of carbon dioxide. Let's do the same for part B. We have calcium nitrate. Whenever nitrate is decomposed, it forms metal oxide along with nitrogen dioxide along with oxygen. We can also balance the equation. Now from balanced equation, we can see that 2 moles form 4 moles of gas, which is nitrogen dioxide, and 1 mole of oxygen gas. So we can say that in total 2 moles will form 5 moles of gases, or 1 mole will form 2.5 moles of gas. As in calcium carbonate, 1 mole of compound forms 1 mole of gas, because this one is solid and this one is only gas. Now let's do the calculations for equal masses. Let's suppose we have 100 grams present. So for calcium carbonate, number of moles will be mass in grams, which is 100 grams divided by mR of calcium carbonate, which is also 100. So it will be equal to 1 mole. So 1 mole calcium carbonate, it will form 1 mole of carbon dioxide. And 1 mole carbon dioxide is equal to 24 decimeter cube. For second one, we have calcium nitrate, so we can take 100 grams of calcium nitrate. So 100 divided by the molecular mass of calcium nitrate, which is 164. It forms 0.61 moles of calcium nitrate. And according to balanced equation, 1 mole of calcium nitrate forms 2.5 moles of gas. So therefore 0.61 moles will form X moles of gas. We can cross multiply. So multiplying 0.61 with 2.5, we can have the value. So it is equal to 1.52 moles of gases. So 1.52 when multiplied with 24 decimeter cube, it is equal to 36.6 decimeter cube. So it means in similar masses, greater volume of gas will be produced in calcium nitrate. Therefore, correct answer is calcium nitrate or part B. Question 21. Which row gives correct comparisons between the solubilities of calcium hydroxide and barium hydroxide and the thermal stabilities of calcium carbonate and barium carbonate? You should remember this: for hydroxides down in group 2, what happens that solubility increases. It means barium hydroxide is far more soluble as compared to calcium hydroxide. For thermal stability of group 2 carbonates, you should remember that as we move down in group, it becomes more thermally stable. So barium carbonate would have higher thermal stability as compared to calcium carbonate, which will be lower. So solubility of barium hydroxide is greater than calcium hydroxide. Now among these we can find the correct answer, which is D. Question 22. Which statement relating to the elements in group 17 and their compounds is correct? Now this one belongs to group 7 of the periodic table, which are halogens. Part A, bromine will reduce potassium iodide to form iodine. We can write the balanced equation or the chemical equation: bromine Br2, it reacts with potassium iodide. As bromine is more active than iodine, so it can displace, so it will form potassium bromide along with iodine. Now we can see whether it is oxidized or reduced. So in potassium iodide, the oxidation state is -1 for iodine, and this one is 0. So from -1 to 0 is called oxidation. So this is not reduction, this is oxidation. Therefore A is incorrect. Part B, iodide ions react to form a white precipitate when added to silver nitrate solution. Now in silver nitrate we have Ag positive and we have iodide. So Ag positive, it can react with iodide to form silver iodide, and silver iodide precipitate, it is not white in color, it is pale yellow in color. Next part C, we have bromide ions that react to form a white precipitate when added to silver nitrate solution. So it will form silver and bromide AgBr, and the color of AgBr, it is not white, again this one is cream color. Last part, chlorine reacts with hydrogen to form colorless gas. Now we can have an equation for that. Chlorine, hydrogen, it can react to form HCl, and HCl is colorless. So correct answer is therefore D. Question 23. An excess of chlorine was bubbled into 100 centimeter cube of hot 6 mole per decimeter cube sodium hydroxide. How many moles of sodium chloride would be produced in the reaction? Let's write the balanced equation for this reaction. We have chlorine present in hot sodium hydroxide. So this one is disproportionation reaction. Chlorine reacts with sodium hydroxide to form sodium chloride, sodium chlorate along with water. Now we can write the balanced equation for this one. Now from balanced equation we can see we have 6 moles of sodium hydroxide which forms 5 moles of sodium chloride. Now let's find the number of moles given in the question. As the formula is number of moles is equal to concentration into volume in decimeter cube, we can put the value. Concentration is 6 mole per decimeter cube, volume is in centimeter cube, so we can convert it into decimeter cube, so it comes equal to 0.6 moles. So if 6 moles make 5 moles of sodium chloride, then 0.6 moles will make X cross multiply, so X equals 0.6 into 5 divided by 6, which is equal to 0.5 moles. Correct answer is therefore B. Question 24. The product of contact process is Z. Which reaction or process leads to the formation of gas that can neutralize an aqueous solution of Z? Now in contact process we make sulfuric acid, which is acid. So the aqueous solution will be H2SO4 aqueous. For neutralizing acid we can have a product that is base. So we need basic gas. Part A is atmospheric lightning. Now what happens in lightning is that nitrogen present in the air, it can react with oxygen present in the atmosphere to form nitrogen monoxide. This nitrogen monoxide, it can further get oxidized to form nitrogen dioxide gas, and this product is acidic. As it is nonmetal oxide, this one is acidic gas. It dissolves in water to form acidic solution, so therefore acidic gas cannot neutralize sulfuric acid. A is incorrect. Part B, combustion of fuel in an internal combustion engine. We have different fuels that are present in combustion engine. Let's suppose the fuel is octane, C8, H18. It combusts in the presence of oxygen to form carbon dioxide and water. Now the gas formed is CO2 gas, and carbon dioxide is also slightly acidic, as it dissolves in water to form carbonic acid, which is weak acid. So acid cannot neutralize acid, so therefore this is also incorrect. Part C is the Haber's process, in which nitrogen interacts with hydrogen to form ammonia. Now ammonia is basic gas, as it dissolves in water or aqueous solution to form ammonium hydroxide. As we have hydroxide ions present, so it can neutralize acid. Part D, thermal decomposition of group 2 nitrates. Now any group 2 nitrate, for example we have calcium nitrate, it can decompose to form metal oxide, nitrogen dioxide and oxygen gas. Oxygen is neutral, nitrogen dioxide is acidic gas, as we have discussed in this one. So acidic gas cannot neutralize an acid. Correct answer is therefore C. Question 25. When ammonia is dissolved in water, a small concentration of ammonium ions is formed. Which row is correct? You have to find out the number of electrons in one ammonium ion, and you have to find out the change of hydrogen nitrogen hydrogen bond angle from ammonia to the ammonium ion. NH4 positive, we had NH3 initially. Nitrogen belongs to fifth group of the periodic table. It has 5 electrons, out of which we have 1 lone pair and 3 bond pairs are formed. Now the bond angle is 107 degrees. When it dissolves in water, it gains a proton and forms ammonium. What happens is that nitrogen, it donates this lone pair of electron to this proton, which has 0 electrons in its shell, so it makes a coordinate covalent bond. Overall charge is positive. Now as we have 4 atoms surrounding the central, element, so therefore bond angle it increases from 107 to 109.5 and it becomes tetrahedral. So we can say that the bond angle increases. Second thing is the number of electrons in ammonium ion. In ammonium ion we have one nitrogen. The atomic number of nitrogen is 7, so it has 7 electrons. We have 3 neutral hydrogen atoms. So we have 3 electrons in total. We also have a proton in which we have 1 proton but 0 electrons as the charge is positive. So overall number of electrons is 7 plus 3, it becomes 10 electrons. Correct answer is therefore D. Question 26. In this question, alkenes and cyclic alkanes should be considered. How many structural isomers of C4H8 are there? So we can make alkenes, we can also make cyclic alkanes. Let's draw the structures. Structural isomers are the ones that have same molecular formula but different structures. So we have C4H8. Let's first draw alkenes. We can have this alkene. This one is but1-ene. As double bond is present between first and second carbon, and in total we have 4 carbon atoms, 1 butene or but1-ene. We can change the position of double bond. Now double bond is in between second and third carbon atoms, so it is but2-ene or 2-butene. Now we cannot change the position of double bond to this one because it will again become 1-butene. So what we can do is that we can change the position of the substituent. Let's draw the third one. We have moved this corner carbon to this double bonded carbon. Again we can see that number of carbon atoms is 4, number of hydrogen atoms is 8. Now in the long chain we have 3 carbon atoms. So this is 2-methyl, as this one is substituent, and we have prop1-ene or 2-methyl-1-propene. Now let's move towards cyclic alkanes. Cyclic means we have cyclic structures. Let's draw 4 carbon atoms. Each carbon when makes 4 bonds, so it has 2 hydrogens. So again this one is C4H8. So this is another structure and the name is cyclo. As we have 4 carbon atoms, so this one is but and all are single, so it is butane. Let's try to draw a cycle of 3. And 4th carbon can be attached like this. This carbon is making 3 bonds, so it has 1 hydrogen. This is making 1 bond, so it is 3 hydrogen atoms. In total we have 8 hydrogens, 4 carbons, and now the name is methyl cyclopropane. So in all these 5 structures, molecular formula is same, so therefore they are structural isomers. Correct answer is therefore C. Question 27. Which compound will decolorize bromine aqueous? Let's find out the functional groups. In part A we have COOH, in part B we have aldehyde, in part C we have alcohol, and we also have less number of hydrogen atoms in between these two carbon atoms. In part D we have CO2. Let's draw these. First one is CH3, CH2, 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 CH2. Then we have C double bond OOH. This one is carboxylic acid. Now carboxylic acid cannot react with bromine aqueous, so it will not decolorize this one. Second one is CH3, CH2, 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 CH2. Then we have this C double bond OH. Now this is aldehyde. Aldehyde also does not react with aqueous bromine. In third one we have this structure. We have CH3, CH, CH, CH2, CH2, CH2 and OH. Also we can see that the number of hydrogen atoms is less over here, so we can make a double bond. Now this is alkene, and what can happen is that alkene, it can react with aqueous bromine in such a way that this carbon is bonded to one bromine, this carbon is bonded to second bromine, and double bond is converted into single bond. So it will be like this. So therefore when bromine is added, it will get decolorized. Part D we have CH3, CH2, CH2, then we have this CO2, C double bond O, O, then we have CH2 and CH3. Now this one is ester. Ester also does not add bromine aqueous, so therefore this is incorrect. Correct answer is therefore alkene, which is in part C. Question 28. Alkenes react with aqueous hydrogen bromide. The reaction proceeds via an intermediate carbocation. The more stable the intermediate, the faster the reaction. Which sequence correctly shows an increase in the speed of reaction of alkenes with hydrogen bromide? In all these four, we can see we only have three compounds, ethene, propene and 2-methylpropene. Let's draw the structure of each of them. We have ethene with 2 carbon atom alkene. We have propene, 3 carbon atoms alkene. And we have 2-methylpropene. On second carbon we have methyl group attached. Now each of them reacts with HBr through an intermediate. Now in intermediate, what happens that one portion it gets attached to one carbon atom, and then second portion will get attached to second carbon atom. So we have CH2. This first carbon, it will be attached to hydrogen from HBr. This second carbon will become carbocation. Now we have Br negative, which is present, and this carbocation, it will be attached to this Br, and final product will be CH3 CH2 Br. Now we can do similar reaction for this compound. We have HBr. Now according to Markovnikov addition, hydrogen goes to the carbon atom making double bond, and that carbon will be the one having more hydrogen atoms. So this carbon has 0 hydrogen atoms, this carbon has 2 hydrogen atoms, so hydrogen will be attached to this carbon. This will be the major product. So if hydrogen is attached to this carbon, then this carbon will become carbocation. We can draw the structure. We have CH3, CH3. Double bond is converted into single bond. And now hydrogen atom is attached to this carbon. And this will become carbocation, which is then attached to Br negative to form final product CH3, CH3, CH2. So on one carbon we have hydrogen, on second carbon we have bromine. Similarly for this one we can do the reaction. Hydrogen will be attached to the carbon having greater number of hydrogen atoms. So this carbon has 1, this one has 2. So hydrogen is attached to this carbon. The product will be like this. CH3, CH, double bond is converted into single bond, and hydrogen is attached to CH2. Now this carbon becomes carbocation. It is then attached to Br negative to form final product. Now in the question it says that the reaction proceeds via an intermediate carbocation. More stable the intermediate, faster the reaction. Let's see which carbocation is more stable. Now in this one we can see that this carbocation is attached to 1, 2, 3 carbon atoms directly. So greater the number of alkyl groups attached with the carbocation, more stable will be the carbocation due to positive inductive effect of these alkyl groups. So 2-methyl propene will be the most stable. In ethene we can see we only have carbocation attached to one alkyl group. In propene we can see that the carbocation is directly attached to 2 alkyl groups. So this one is more stable as compared to alkene. So ethene will be least stable carbocation. As more stable carbocation means fastest reaction, so therefore increase in speed will be in such a way that ethene will be the slowest, propene will be faster, and 2-methyl propene will be the fastest. So correct answer is A. Question 29. A reaction occurs when a sample of 1-chloropropane is heated under reflux with sodium hydroxide dissolved in ethanol. Which row is correct? You have to find out the type of reaction and name of product that is formed. Now we have 1-chloropropane. In propane we have 3 carbon atoms. On first carbon we have chlorine attached. Rest are the number of hydrogen atoms. Now when heated with sodium hydroxide ethanolic, elimination takes place. Elimination means the removal of a molecule, so chlorine atoms gets removed from this carbon, and from adjacent carbon hydrogen atom will be removed and alkene is formed. So the product will be like this. We have alkene. This one has lost chlorine. This one has lost one hydrogen. Now in the presence of sodium chloride, Na will react with Cl to form NaCl, while the hydrogen that is lost, it will react with OH negative to form water. So the type of reaction is elimination, it is not substitution, and the name of product that is formed, it is prop-1-ene or simple propene. Correct answer is therefore B. Question 30. The diagram shows the structure of 3 halogenoalkanes. We have this one, and this one. P, Q and R can all be hydrolyzed. Which row is correct? First you have to find out the speed of hydrolysis between Q and R and mechanism of hydrolysis among P and Q. Let's first see the speed of hydrolysis. So we can see in Q we have Br attached to carbon atom, which is just one methyl group, CH3. In R, chlorine is attached to CH3. So both have single methyl group attached, and therefore the rate of hydrolysis, it will not depend on the number of alkyl groups, it will depend on the strength of the bond between carbon bromine and carbon chlorine. Weaker bond means faster hydrolysis, stronger bond means weaker hydrolysis. As CCl bond needs 346 kilojoules per mole to break and C-Br bonds need 290 kilojoules per mole to break, so this one will break more easily as compared to this one. So this one will be faster reaction as compared to R, so Q will be fast. Second thing is the mechanism of hydrolysis among P and Q. In P we can see that the alkyl group is attached to this carbon, which is directly attached to 3 methyl groups. So this one is called tertiary halogenoalkanes. In Q we can see that the halogen is attached to this carbon, which is attached to no other carbon atom, so this one is primary halogenoalkane. Primary halogenoalkane, it always follows SN2 mechanism, in which we have two reactants present. One is OH negative as we are doing hydrolysis, second is CH3Br. So what will happen that this OH negative, it will attack this partial positive carbon and this bond will be removed. While in tertiary halogenoalkanes, the mechanism of hydrolysis is called SN1 mechanism. This is because in the first step or slowest step only one molecule is involved, which is this one. So first what will happen that this molecule, it will get dissociated in such a way that it becomes carbocation and Br negative is lost. So as only one reactant is present in the rate determining step or slowest step, so therefore this will follow SN1 mechanism. So SN1 for P and SN2 for Q. Correct answer is therefore A. Question 31. A sample of 2.30 grams of ethanol is mixed with an excess of aqueous acidified potassium dichromate 6. This is oxidizing agent. The reaction mixture is boiled under reflux for 1 hour. The required organic product is then collected by distillation. The yield of product is 60%. Which mass of product is collected? Let's write the balanced equation. We have ethanol, which is C2H5OH. This is alcohol. It gets oxidized by potassium dichromate 6. So we can write O instead of oxidizing agent. Now whenever alcohol is oxidized, it gets converted into carboxylic acid whenever it is under reflux. So it will make CH3COOH. Now we have 2 carbon alcohol, it will make 2 carbon carboxylic acid. So ethanol is converted into ethanoic acid along with water molecule. Now they have given 2.30 grams of ethanol. We can convert it into number of moles. So 2.30 grams is the mass. Let's find the molecular mass. 2 carbon, 24 plus 5 for 5 hydrogen plus 16 for 1 oxygen and 1 for 1 hydrogen. So it comes equal to 46. So 2.30 grams divided by 46, it comes equal to 0.05 moles. From balanced equation, we can see that 1 mole of ethanol gets converted into 1 mole of ethanoic acid. So 0.05 moles of ethanol gets converted into 0.05 moles of ethanoic acid. Now let's find the mass in grams of ethanoic acid. The molecular mass is, we have 12 for 1 carbon, 3 for hydrogen, 12 for another carbon, 32 for these two oxygen, 1 for hydrogen. So in total the molecular mass is equal to 60. Now converting number of moles into mass in grams, mass is equal to number of moles into mR. So it will be 0.05 into 60 and it comes equal to 3.0 grams. Now this is the organic product given in grams. It says that the yield of product is only 60%. So we can find 60% of 3 grams. So 60% of 3 will be equal to 60 divided by 100 into 3. So it comes equal to 1.8 grams. Correct option is therefore C. Question 32. The structure of tartaric acid is shown. We have this tartaric acid. 4 moles of substance X reacts with 1 mole of tartaric acid. What could be substance X? We have sodium, sodium carbonate, sodium hydrogen carbonate or sodium hydroxide. Let's find the functional groups present in tartaric acid. We have carboxylic acid. This one is also carboxylic acid functional group. This one is alcohol functional group. This one is alcohol functional group. Now first one is sodium. Sodium is a metal and it can react with alcohol to form sodium alkoxide. It can also react with carboxylic acid to form sodium salt of carboxylic acid. So the product will be like this. Sodium will react with carboxylic acid to form ONA, sodium salt. It will react with alcohol to form alkoxide, ONA. It will react again with this alcohol part similarly and this one in similar manner. So we can see that on 4 parts we have the reaction taking place. So we need 4 moles of sodium. So it says 4 moles of substance X reacts with 1 mole of tartaric acid. So A is correct option. Part B is sodium carbonate. Now carbonate does not react with alcohol. Carbonate only reacts with carboxylic acid part. Sodium carbonate reacts with carboxylic acid to form sodium salt of carboxylic acid along with carbon dioxide and water. So only 2 moles will be needed, one for this part and one for this part. So for this we need 2 moles, which is incorrect. Third one is sodium hydrogen carbonate. Now sodium hydrogen carbonate also reacts similarly as sodium carbonate. It will also make salt and water with carboxylic acid functional group. So therefore 2 moles will be needed. It does not react with alcohol. Part D is sodium hydroxide, which is alkali. Alkali reacts with acid part. It does not react with alcohol. So again only 2 portions will be reacting. 2 will be left behind. So we need 2 moles of sodium hydroxide. So the only part for which we need 4 moles is sodium metal. So therefore answer is A. Question 33. Which compound gives both an orange precipitate with 2,4-D and pH, which is dinitrophenylhydrazine, and a yellow precipitate with alkaline aqueous iodine? For 2,4-D and pH, you should remember that only aldehyde and ketones, they can give positive result. For yellow precipitate with alkaline aqueous iodine, there must be a methyl group directly attached to carbonyl carbon. Let's draw the structures. First one is ethanol. Ethanol is CH3CH2OH. Now it is neither aldehyde nor ketone. This one is alcohol, so it will not give orange precipitate with 2,4-D and pH. Second one is methanol. Methanol is aldehyde having just one carbon atom. So we can draw an aldehyde. We only have just one carbon atom and that is this one. So this will give orange precipitate with 2,4-D and pH as it is aldehyde, but as it does not have any methyl group attached to carbonyl carbon, so a yellow precipitate will not be formed. Third one is propanol, CH3, 3 carbon propanol, CH2, C double bond OH. This is aldehyde, so it will give positive result with 2,4-DNPH. But instead of methyl group with carbonyl, we have ethyl group, so it will not give yellow precipitate with alkaline aqueous iodine. Last one is propanone. Propanone means ketone of 3 carbon atoms. So we can draw this one. We have 1, 2, 3 carbon atom ketone. As it is ketone, it will give positive result, orange precipitate. And we also have methyl group directly attached to carbonyl carbon, so it will also give yellow precipitate. So correct answer is part D. Question 34. A student suggests 2 uses of lithium aluminium hydride. In first reaction, alkene. In the presence of lithium aluminium hydride, it converts into alkane. In second reaction, carboxylic acid, it gets reduced to alcohol. 2 carbon carboxylic acid ethanoic acid converts into 2 carbon ethanol. Which reactions would give the product shown? Now reaction 1 is from alkene to alkane. This does not occur in the presence of lithium aluminium hydride. Instead, we need hydrogenation in the presence of nickel. Reaction 2 is carboxylic acid with reducing agent, as LiAlH4 is powerful reducing agent, so it can reduce carboxylic acid to alcohol. So therefore reaction 2 is correct. So we can say that only reaction 2 is correct, so therefore answer is C. Question 35. Compound X contains a single ester group. X contains 27.6% by mass of oxygen. Which pair of products could be produced by the hydrolysis of X? Now these are the products. So we can deduce the reactant from this product. If we have butane, 1-ol and ethanoic acid, the reactant must be butyl ethanoate. So this will be X. For second one, it will be ethyl propanoate. Similarly, for third one, methyl methanoate. And for part D, we have propane 2-ol and butanoic acid, so it is isopropyl butanoate. Let's draw the structures of these. First one is butyl ethanoate, so we have 1, 2, 3, 4 carbon atoms from alcohol part. And as it is ethanoate, so we have 2 carbon atoms from acid part, 1 and 2. For ethyl propanoate, it will be 2 carbon atoms from alcohol part. And as it is propanoate, so 3 carbon atoms from carboxylic acid part. Similarly, methyl methanoate, 1 carbon atom from each side. Isopropyl butanoate, we can draw the structure as it is on second carbon alcohol. So it will be like this. And butanoate means we have 4 carbon carboxylic acid. 1, 2, 3, 4. Let's find the molecular masses. Carbon is 12, hydrogen is 1, so 12 plus 3 it becomes 15, 12 and 2 it is 14, this one is 14, this one is 14. 32 for 2 oxygen atoms, 12 for carbon, 15 for CH3. So combining all of them together, the MR it comes equal to 116. In second part, we have 15 plus 14 plus 32, 12, 14, 15. So overall it comes equal to 102. For third part, we have 15 plus 32, 12 and 1. So this one is equal to 60. In last one, we have 15, 15, 13, 32 for 2 oxygen, 12, 14, 14 and 15. So combining all of these together, it comes equal to 130. Now let's find the percentage of oxygen by mass. It must be 27.6%. We can do for each of these. As we can see, only 2 oxygen atoms present in each of the compound given. So percentage of oxygen, it will be equal to number of atoms of oxygen, which is 2, into atomic mass of oxygen, which is 16, divided by the molecular mass of compound. For first one, the MR is 116 into 100. So calculating this one, it comes equal to 27.58%. So this one is equal to given in the question, so it could be A. Now doing the same for other parts. For part B, the MR is 102, so percentage of oxygen will be 32 divided by 102 into 100. It is 31.37%. This is incorrect. For part C, 32 divided by molecular mass, 60. It comes equal to 53.3%. For part D, 32 divided by, we have 130. So it is equal to 24.6%, which is also incorrect. So only correct option is part A. Question 36. What is the least number of carbon atoms in a non-cyclic alkane molecule that has a chiral center? So we can have non-cyclic alkane. Alkane means all bonds should be carbon-carbon single bonds. So we can make a chiral carbon or chiral center. Now chiral carbon is the one that is attached to 4 different groups or elements. So in this case, we can have minimum number of carbon atoms attached to this one. So first we can attach a hydrogen atom, which means we have 0 carbons. Then we can attach 1 carbon atom in the form of CH3. Then we can attach 2 carbon atoms. Then we can attach 3 carbon atoms. Now we can see that all 4 groups are different. This one is propyl, this is hydrogen, this is methyl, this is ethyl group. So this carbon is chiral. Now total number of carbon atoms is 1, 2, 3, 4, 5, 6, 7. So we can make a chiral center out of 7 carbon atoms. Question 37. A molecule of a polymer contains the sequence shown. This is the sequence. We can see we have CH2, we have carbon-chlorine bond. Which monomer could produce this polymer by addition polymerization? So for addition polymerization, we need alkene or double bond, and it is present in all of them. Let's see which monomer produces this kind of polymer. So we can take the first one. We have carbon, hydrogen, chlorine with the first carbon, then double bond, carbon, hydrogen, chlorine with second carbon. So if another similar monomer comes, it will make a polymer like this. We have CC HCl on each carbon atom. All double bonds are converted into single bonds and new bonds are formed between monomers. But in the structure we can see that a chlorine atom is not present on each of the carbon atom. There are carbon atoms having only hydrogen atoms, so therefore A is incorrect. Part B, we have CH2, CHCl. So with first carbon we have two hydrogens. With second carbon we have hydrogen and chlorine. Now it can react in two ways. One is that it can react with another monomer like this in the same sequence. And polymer formed will be like this. On first carbon atom we have two hydrogens. On second carbon we have hydrogen and chlorine. On third carbon atom again we have two hydrogen atoms. Fourth carbon we have hydrogen and chlorine. So we have alternate chlorine atoms and alternate hydrogen atoms. But in the structure we can see that the chlorine atom come adjacent and sometimes they are alternate. So this means that polymerization is like this, as we have hydrogen, then chlorine, then hydrogen, then chlorine. Another possibility is that we have CH2, CHCl. It can react with similar molecule, but now this molecule is inverted. This chlorine is on first carbon and we have two hydrogens on second carbon. Now the polymer formed will be like this. On first carbon we have two hydrogen atoms. On second carbon we have hydrogen and chlorine. On third we have hydrogen and chlorine. On fourth we have two hydrogen atoms. Now we can see now chlorine have come adjacent, as was the case in this one. So therefore B could be the correct option, as it can form this kind of polymer. Let's do the third one. We have CH3CCl. So what happens that in this one we have methyl group attached as a substituent with carbon which is attached to chlorine, and on second carbon we have hydrogen and chlorine. So in the polymer there must be a substituent attached which is methyl group, as we can see that in this given polymer we only have hydrogen atoms and chlorine atoms. No methyl group is attached, so therefore this is incorrect. Again, part D is also similar. We have CH3, then carbon, chlorine, and on second carbon we have two hydrogen atoms. So as CH3 is not present in the polymer, so therefore this is also wrong. Correct answer is therefore part B. Question 38. Compound Y is heated with the mild oxidizing agent. One of the products of the reaction reacts with hydrogen cyanide, forming 2-hydroxybutane nitrile. What is compound Y? Let's first draw the structure of this product that is formed. We have 2-hydroxybutane nitrile. In butane we have 4 carbon atoms, and as it is nitrile, so we have C triple bond N also present. On second carbon atom we have hydroxy, so this is first carbon, as it is bonded to nitrogen. This is second carbon, hydroxy, rest are the number of hydrogens. Now as the reaction involves hydrogen cyanide, it means HCN is added. So whenever CN is added, it increases one carbon atom. So in product we had butane, which means we have 4 carbon atoms. So it means in the reactant we must have 3 carbon atoms that become 4 carbon on the addition of cyanide. So let's see which one produces 3 carbon product. So we have butane 1-ol. Butane 1-ol is CH3, CH2, CH2, CH2 and OH, primary alcohol. As we can see, we have 4 carbon alcohol, so it is oxidized into 4 carbon aldehyde first. So we have CH3, CH2, CH2, C double bond OH. And 4 carbon aldehyde, when added to HCN, it will become 5 carbon nitrile. Now we have 4 carbon nitrile, so therefore this is incorrect. For butane 2-ol, we can add OH group to second carbon atom. Now mild oxidizing agent will change this secondary alcohol to ketone. Will change this secondary alcohol to ketone. And on addition of CN, we will have 5 carbon product. So therefore this is also incorrect. We can use propane 1-ol or propane 2-ol. Now let's look into the case of propane 1-ol. We have CH3, CH2, CH2OH. It is first mildly oxidized into aldehyde. CH3, CH2, C double bond OH. Now in the presence of HCN, what will happen, that this oxygen, it gets converted into OH, and this CN, it gets attached to this carbon atom. So product will be like this: CH3, CH2, COH, CN. Now we can see this is first carbon, this is second carbon, third and fourth. So it is 2-hydroxy. As we have 4 carbon atoms in the long chain, so it is butane. And due to the presence of triple bond with nitrogen, it is nitrile. So it means propane 1-ol could be correct option. Let's look into propane 2-ol. What will that form? Propane 2-ol, we have alcohol on second carbon. It is converted into ketone on oxidation. And when hydrogen cyanide is added, it will form this product. Oxygen becomes OH, carbon gets attached to CN, and we have CH3 group present. Now in the long chain, we can see we have 1, 2, 3 carbon atoms in the long chain. This one is a substituent, this is also a substituent. So on second carbon we have methyl, on second carbon we have hydroxy. So it will be 2-methyl, 2-hydroxy, propane nitrile. As we have 3 carbon atoms in the long chain, and it also has a triple bond. So this one is incorrect. The only correct option is therefore C. Question 39. The diagrams show the structures of lycopene and beta carotene. We have one, this one, and second is this one. When lycopene is converted into beta carotene, what is the gain or loss of hydrogen atoms per molecule? Let's look into the structure if there is any change. So now we can see that there is a change on these 2 carbon, and there is a change on this carbon. Rest is similar. Then again we can see that there is a change on this carbon, and on these 2 carbon atoms double bond has changed. Now let's look into each carbon atom. This one is the first carbon, it is not bonded to any hydrogen atom. This carbon is making 3 bonds, so it is also attached to 1 hydrogen. This carbon is making 3 bonds, so it is also attached to 1 hydrogen. Similarly, this carbon is attached to 1 hydrogen. This is attached to 0 hydrogen as 4 bonds are completed. This one is attached to 1 hydrogen. Now in the product, this carbon is attached to 0 hydrogen, this one is attached to 2 hydrogen atoms. This one has 4 bonds, so it has 0 hydrogens. 0 hydrogen for this one, 2 for this one, 0 for this one. As we can see, we had 2 hydrogen atoms on different carbons. Now we have 2 hydrogen atoms on the same carbon. So there is no change in number of hydrogens. Similarly, we had 2 hydrogen atoms on different carbons. Now we have 2 hydrogen atoms on same carbon. So there is no change in number of hydrogens. So correct answer is C. Question 40. Which diagram shows the infrared spectrum of a compound that contains both a carbonyl group and a OH group? They have given different structures A, B, C and D, and we also have this table. In table we can see the position of carbonyl carbon and OH. For carbonyl carbon we have 1640 to 1750, and for carbonyl the peak is sharp and strong. For OH, we have 2500 to 3650, and it is quite a wide range, and the peak is wide peak. Let's look into the structures which contains both of them. First, let's see this peak. We have this one at 1750, and in this one the carbonyl peak this one is at 1700, in this one the peak is at 1500, and in this one the peak is present at 1500. So the carbonyl peak, it must be between 1640 to 1750, so it means C and D are incorrect. In A and B the peak comes between 1640 to 1750, so it could either be A or B for carbonyl carbon. So this peak could be of carbonyl, this peak could be of carbonyl. Now let's see the broad peak of OH. Now we can see there is no broad peak or wide peak between 25 to 35, and in part B we can see we have this broad peak. So therefore this is due to the presence of OH. Correct answer is therefore B.
Thanks for watching. If this was useful, please do like, subscribe and share.